Alright, welcome back to another video on my channel, my underscore EXE. Today we're going to look at another problem solving question. So this figure shows two right angle triangles ABC and ACZ. Here X is the midpoint of the line segment AC, as well as the dimensions shown here at the diagram. Find the magnitudes of the lengths of line segments CY and BY such that Y is on the line BC and points X, Y, and Z are collinear. And what I mean by the term collinear, it means they lie on the same line. So let's just draw a representation. So let's say point Y is here. And we must ensure point Y is such that if a line intersects, we must have a line intersecting all the points X, Y, and Z. And we call points X, Y, and Z are collinear if a line can pass through all 3 points here. And as you can see, it's not quite passing through Z, and we can just figure that out mathematically. And actually we're going to use a trick which is called Menelaus Theorem, and the theorem states like so. So assume we have a scaling triangle ABC, and that we have a line segment just intersecting through 2 points on 2 different line segments of the triangle, and we'll call them points E and D respectively. And then it intersects to this point F here. And I should have mentioned that ABF is a straight line as well. So if we have this setup, we can say that AF over FB times BD over DC times CE over EA is equal to -1. But you might be wondering, how can a line segment be -1? Well, this theorem uses the sign convention that if you assume we have 2 points right here, and if you travel from this point to the right to this point, that distance will be positive. And on the other hand, if you travel from this point to this point, so you travel to the left, that will be considered negative. And the way you remember these line segments, as you can see, it appears to be random, is as so. So this is how I would remember this. So you go AF, so you have to go here, and you notice you go from A to F, you travel to the right direction. That will be positive. Over FB, so you go to the left here, that will be negative. Times BD, you go up here, but notice you go slightly to the left a bit, so this will be negative. Over DC, again, same thing, negative. Times CE, also negative since you go to the left a bit, times EA, which is also negative. So as you can see, you have this loop right here, which is very, very nice. So I'm just going to clear up all these details, unnecessary details on this board, and let's just work things out. So from this, you might want to find some dimensions of unknown lines, and you can just do that by using the Pythagorean Theorem. So I can actually find the length of BC by knowing that AB is 6 centimeters, and the length of AC will be 8 centimeters. And if you just quickly calculate that, you'll get the length of BC is 10 centimeters. And I should have said the magnitude, since I wouldn't want you to be confused with the sign convention in Menelaus Theorem and just like the lengths of the triangles in general. So that's one length done. And let's see. Well, we can just look at triangle ACZ, and we can just find the length of AZ which is this length right here, by knowing that the hypotenuse is 17 centimeters and the opposite length here will be 8 centimeters. So quickly calculating that, you'll get 15 centimeters. And since the whole thing right here, since the whole thing of AC is 15 centimeters and this little bit here is 6 centimeters, therefore this bit will be 9 centimeters. Alright, so let's see. Well, we can just use the setup for Menelaus Theorem. So we want x, y, and z to be collinear, and we have E, D, and F are collinear. So you must have y, which is our unknown point on the line BC. So let's just say it's on right here, or probably up a bit. So well, assume that we have a line passing through Z. Well, it's not pretty accurate, but let's just assume that it is. So let's just use Menelaus' theorem right here. So we have AF, which is just the length of AZ, and then we go left here, and then we go up here, we go up here, and then we go down here, and then go down here. So we have formed our loop as we intended to in Menelaus' theorem. So I'll just write down the thing right here. So we must follow the sign convention of Menelaus' theorem. So since we go A right to Z, that means our distance will be positive 15 centimeters. Over, since we're going left 9 centimeters, therefore that will be negative 9 centimeters. Multiplied by, well, we have by over yc, which we currently don't know yet. So let's just write that in. And we have cx and xa, and those could be either negative or positive. However, since they have the same sign, since they go on the same direction, and they're equal in length. In fact, since we know that cx equals xa, that will be just 1. Or you can just calculate the distances of cx and xa respectively, and you get 4 centimeters and 4 centimeters respectively, and that will simplify to 1. And by Menelaus' theorem, this must be equal to negative 1. And notice this negative and this negative will cancel, leaving us with by over yc. This will be equal to 9 over 15. However, we can just rewrite this slightly differently. So we have by is equal to 3 over 5 yc. But notice here, let's see, BC, which is the whole thing, is equal to 10 centimeters. And we know that BC, well, I should have said the magnitude of the length BC is formed by adding the magnitude of by and the magnitude of yc. But since we know BC is 10 centimeters, by, but we can just substitute this in here. We have 3 over 5 yc plus yc. Solving for yc, you'll get the magnitude of yc will be 6.25 centimeters. And if you substitute this into our original property here, you'll get that by will be equal to 3.75 centimeters. And those are our answers for this problem. Alright, so that's it for this video, and it's pretty long as well. So hope you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.